Problem number 8, we want to find all values of x between 0 and 2 pi that satisfy the equation. We're giving exact radian answers. So part A, sine x equals -1. When I see a sine ratio of -1, of course I think that's probably a coordinate on the unit circle. On the unit circle, the sine function gives you the b coordinate. So I'm looking for a point here, something comma -1. Well, there is only one such point. This is the only something comma -1 point on the circle. It is 0 comma -1, which means there is only one angle between 0 and 2 pi that makes this equation true. It is 270 degrees, or in radians, 3 pi over 2. Part B, cosine x equals 0. Again, zeros, ones make me think of the unit circle with sine and cosine. So cosine represents the a coordinate on the unit circle. I need a point 0 comma something. There are two of them. One of them is right here, 0 comma 1. The other one is the one from part A, 0 comma -1. Those are the only 0 comma whatever points on the circle, which means between 0 and 2 pi, I've got this angle here, and I've got this angle here. In other words, there's two answers. I've got pi over 2, and once again, I've got 3 pi over 2. Part C, tangent x equals 0. Let's see, on the unit circle, tangent returns to me the b coordinate divided by the a coordinate. The only way that's going to come out to be 0 is if the top part is 0, because 0 divided by anything is 0. So I'm looking for places where the b is 0, something comma 0. It's going to happen here at 1 comma 0. 0 divided by 1 would be 0, and it's going to happen here at -1 comma 0. So what two angles will I give? Well, you got to pay attention back up here. I want 0 to 2 pi, including 0 because of the little equals, not including 2 pi. So don't say 2 pi for this one. You'd have to say 0 radians for that first one, and then obviously the second one would be pi radians. So 0 and pi, not 2 pi, because that was not part of our interval. Problem number 9, I'm given a list of numbers summarized by an equation. The directions say that k, in this case, stands for all whole numbers. So starting at 0 and then going 0, 1, 2, 3, etc. We just want to write down the first 5 items in each list. So the first one would be found by simply plugging in k as 0. I think you can do that in your head. You'd just have pi over 2. The next one would be plug in k is equal to 1. So I'd have pi over 2 plus a single pi. Of course, I'm going to have to do some math here. I got to think of pi as 2 pi over 2. Pi over 2 plus 2 pi over 2 would be 3 pi over 2. How do I get the next one? Well, just keep adding another pi. That's really all that happens. When you plug in k as 2, now you'd have pi over 2 plus 2 pi, or another way to think of that is pi over 2 plus pi, the one I had before, plus yet another pi. Just keep adding 2 pi over 2 to this thing. That's going to take you to 5 pi over 2, 7 pi over 2, 9 pi over 2, and on and on. We just wanted to write down the first 5. Okay, let's take a similar approach for part B. Obviously, the first one is going to be pi over 4 if I fill in 0 for k. Let's see what happens if I fill in 1 for k. So I'm going to get pi over 4 plus a single pi over 3. Then for the next one, I'll add another pi over 3 and another pi over 3 and so on. Here my common denominator is 12. So I'll think of this one as 3 pi over 12. And I'll think of this as 4 pi over 12. It will be helpful throughout this problem to think of pi over 3 as 4 pi over 12. Of course, when I add that together, I get 7 pi over 12 as my next item. Well, all I have to keep doing is adding another pi over 3. Maybe better to think of it as adding another 4 pi over 12. Well, if I add another one, I'm going to get to 11 pi over 12. And if I add one after that, I'll get 15 pi over 12, and then another one after that, 19 pi over 12. All that's really happening here is adding 4 to the top as I go along there. I will say one of these answers needs to be simplified. Maybe you noticed that as I was writing it down. 15 and 12 have a common factor of 3. So this simplifies to 5 pi over 4. And of course, we're always giving the simplest answers. The fourth item in my list would be 5 pi over 4. Here then are the 5 final answers. Problem number 10 is kind of like problem number 8. We want to find all the values of x in between 0 and 2 pi, including 0, but not 2 pi, that satisfy the given equation. We're going to give exact radian answers once again. I don't have unit circles this time because the ratios are triangle ratios, so we'll be drawing some triangle pictures. Let's see. Sine x equals -1/2. My first decision to think about is what quadrant should I be drawing my picture? Well, let's see. All students take calculus. Sine is only negative in the third quadrant as well as the fourth quadrant. I'll have to draw both because I want all the answers between 0 and 2 pi. Let's see. Sine is opposite over hypotenuse. Opposite over hypotenuse. This is just our 30, 60, 90 triangle that we draw all the time. The angle opposite the 1 is 30 degrees, right? So that's a little 30 and that's a little 30. Here are the two angles we have found. One of them is a third quadrant angle right there. Looks like it's 180 plus 30, 210 degrees, otherwise known as 7 pi over 6. And the other angle is a fourth quadrant angle, 30 degrees short of 360. That would be 330 degrees, which is 11 pi over 6. It's all about the pictures, thinking about the quadrants. Here are the only two angles between 0 and 2 pi that make that equation true. Letter B, cosine x equals √3 over 2. Cosine, let's see, where is cosine positive? Obviously in the first quadrant, and then all students take calculus in the fourth quadrant would be the other spot. Cosine ratio is adjacent over hypotenuse. This is another 30, 60, 90 triangle. In fact, it's the same one. The reference angle is the same thing because the 30-degree angle is always opposite the 1. I've got a little 30-degree angle there and a little 30-degree angle there. I have two angles that I'm looking at here. One is just the simple first quadrant angle, 30 degrees, which is pi over 6. The other one is the fourth quadrant angle. It's the same one we had in the last picture, 30 degrees short of one full revolution, which is 11 pi over 6. And so there are my two answers. And then part C, where is the tangent function negative? Well, it's positive in 1. All students take, it's positive in 3, so it's going to be negative in the other two places, quadrants 2 and 4. Tangent is opposite over adjacent. Maybe it's helpful if I write that -1 over 1. So these are both just 1s. Here the x would be negative. In the other picture, the y would be negative. What angle is this? Well, of course, these are just our 45, 45, 90 triangles. So this is a little 45, and this is a little 45. What two angles are we talking about here? The second quadrant angle, having to do with 45 degrees, is 3 pi over 4. It's 135 degrees. And then the fourth quadrant angle, having to do with 45 degrees, is 315 degrees, which is 7 pi over 4. And so we've got our solutions.